Okay, once we have the basics on what the mole is, we are going to begin with the calculations. The first thing is going to be calculating the molar masses. We did this before, but just in case you didn't realize that we were calculating the molar masses. For example, if we need to calculate the molar mass of the nitric acid, it's important that we have the formula. If not, we cannot calculate that. And the molar mass is going to be the mass of 1 mole of the compound. So we just have to add up all the masses of all the elements that are in the compound. In this case, the hydrogen appears once in the formula, the nitrogen appears once as well, and the oxygen appears 3 times. That's why I'm multiplying the mass of the oxygen times 3. In this case, it's going to be 1 plus 14 plus 48. The molar mass of the nitric acid is 63 grams per mole. In the second example, the calculating masses, we have 2 options. First is going to be calculating the masses based on the number of moles that they give us. So we are going to use always the relationship of 1 mole of sulfuric acid is equals to 98 grams, and it contains 6.02 times 10 to the 23rd molecules of sulfuric acid. That is the relationship that we build in all the video number 1. If you don't understand where I got this from, please watch the video number 1 again. So after we calculated that the molar mass of the sulfuric acid is 98 grams per mole, following the same steps on the example number 1, we can begin resolving our exercise. It says which is the mass of 0.5 moles. So under the mass, I'm going to put an X. That is what I need to calculate. How much is the mass? And under the moles, since they give us that as data, we put 0.5 moles. Now, if we need to resolve for X, we are going to multiply these 2, and here you have the thick line is going to see what we need to calculate, and we are going to divide by, in this case, 1. So my X is going to be 0.5 moles times 98 grams of sulfuric acid divided by 1 mole of sulfuric acid. Remember that it's important that you put the units. If you don't put the units, you may have the wrong answer and don't realize about that. In this case, moles and moles are canceled, and my answer is going to be in grams, which I wanted. It says which is the mass. In this case, X is equals to 0.5 times 98, which is 49 grams of sulfuric acid. The second part of this same example of calculating masses is calculate the mass of, in this case, 1 molecule. It can be 10 molecules, it can be 1 million molecules, it doesn't matter. So we need to calculate the mass. So again, I put the same relationship, 1 mole, the molar mass, and 6.02 times 10 to the 23rd molecules of sulfuric acid. The X is going to be again under mass, but now I need to calculate 1 molecule of sulfuric acid. How much is going to be the mass? So I need to multiply these 2 divided by 6.02 times 10 to the 23rd. Now, X is going to be 98 grams of sulfuric acid. Remember the units are important, times 1 molecule of sulfuric acid divided by 6.02 times 10 to the 23rd. Now, the molecules and molecules are cancelled, and my answer is again in grams. The only problem sometimes is how to use the calculator. Different calculators can express the numbers in different ways, and also they are going to have different keys. In this particular one that I have, the X key is going to be the one that I use to enter the value. So I put 98 divided by 6.02 exp 23, and it's going to give me 162 or 163 rounded times 10 to the 22nd negative grams. That is because the mass of only 1 molecule is really, really tiny.